Hello everyone and welcome back to Arctic Retro. Today we're gonna have some fun with this little guy here. This is a brand new 8-bit computer. So this is the Agon Light computer, and this is the Origins edition, and this is an 8-bit computer based on the Z80 CPU, and it was made by Bernardo, also known as the Byte Attic, and he has a lot of cool videos on YouTube. You should definitely check out his channel, and there's a lot of information about this and other products he has made, so check it out. Before I get into the details about this computer, let's check out the PCB, and yeah, it looks very nice. Agon Light Origins edition, and that means that this is final, or yeah, an edition that is more complete than the first one, which was considered a beta version. It says here Agon Light, the black belt of 8-bits revised and enhanced for discerning hobbyists, and it's signed by Bernardo. So if you're interested in having made PCBs like that, you could always check out my sponsor PCBWay. So if you want to buy this board finished, then just head over to PCBWay.com, and here you can see the Agon Light. There's a discount now and it costs $99 US. Besides making pre-populated boards, they can also take care of other of your hobbyists' needs. They do PCB prototyping, PCB assembly, FPC rigid flex, advanced PCB, CNC and 3D printing, and SMD stencils. And right now they are hosting their 6th project design contest. If you have made your own design that you want to share, then you can participate in this contest, and there's great prizes for you to win. So head over to PCBWay right now. So what is the Agon Light, you might ask? Well, let's take a look at the Byte Attic's website, where you can find all the details, and yeah, it states Agon Light is a fully open sourced 8-bit microcomputer and microcontroller in one small low-cost board, built with the state-of-the-art 21st century technology. And it claims to be the fastest and cheapest 8-bit microcomputer ever made. A little bit about the technical details here. It has a EZ80F92 CPU, which is Z80 compatible, but a modern one, and it's running at 18.4 MHz, and it has a 24-bit address bus. It also features a ESP32 Pico VDP, a video display processor running at 240 MHz, and it comes with 512 kilobytes of RAM. Audio video memory is 8 MB, and it supports video modes VGA at 640 x 480 pixels with 64 colors simultaneously. Audio is a dedicated core within the VPD, and it supports PS2 keyboards, but you can also use some older USB keyboards if you have an adapter. For storage, it uses a micro SD card, and it also has 20 GPIO pins out, where you can experiment if you want to hook up some additional hardware, or experiment about making something yourself. And it also claims here that there are no FPGAs and no emulation in it. When you turn the machine on, it instantly boots into BASIC, and it's a version of the BBC BASIC actually. Let's take a closer look at the hardware. Here's the GPIO ports, and yeah, that's probably a programming port. Micro SD card. Reset button, and this is the USB power input, 5 volts. VGA connector for video, 3.5mm jack for audio and the PS2 connector for the keyboard. There's a couple of pin headers there. I'm not really sure what those are for. Little speaker, probably voltage regulator there. Yeah, looks very nice and very tiny for a computer that capable. Alright, so let's hook it up now and see if it actually powers on. It already came with a built-in SD card, so need to explore what's on that. Just want to say thank you to Bernardo, the Byte Attic. He sent me this for free for me to review, so grateful about that. Always fun to test out something new. Hooking this up, I just use this small little USB power supply. And I have a USB cable. Also, we obviously need a keyboard. I found this old keyboard lying around. It has this weird plug here, which means it can be used on old XT machines, I think. And it also has this PS2 connector. So I guess it's gonna work. I actually tried a more modern USB keyboard with this dongle, but that did not work. And then we have a VGA cable that I have hooked up to my good old TV here. So that's all there is to it. Alright, let's turn it on and see what we get. Oh, that was fast. It actually booted within 1 second or so. Yeah, so there we have it. It says BBC Basic Set 80 version 3.0. Do the keyboard work? Yes, it does. Mistake. Okay, we need to try the obligatory 10 print hello. This is a Norwegian keyboard, so I'm not really sure where the different keys are. Let's see now. Okay, mistake in line 10. Probably I needed to use uppercase. Not really sure. There you go. And that was blistering fast compared to other old retro machines that I have used before. Alright, so let's see what we can do with this little computer. Unfortunately, I don't have any way of capturing VGA output, so I simply have to film the screen, but I think it looks alright. I have turned down the lights in the room. So the operation of this machine is kind of layered into 3 layers. The first layer, which is the VDP, is loaded. That is loaded from firmware, and that's the only thing you need, that additional program import to update, but we're not going to do that here today. The next part is the Agon Quark MOS, which is a kind of a command line operating system for the machine. And then the third layer is applications, and this is now BBC Basic. It has loaded it automatically. If you have that on the memory card, it will load it up. Or you can set the machine up to load something else from the memory card if you want to do that. So if we take out the memory card and boot the machine again, it will only load the 2 first layers. And now we are in that command line mode, and you can type some commands here to inspect the machine. For example, cat for looking on the memory card, which I now have inserted. It shows the content of the memory card, and here we can see that the BBC Basic.bin is actually on the memory card, and if we want, we can now load it. And run. So now we're back into Basic, and if we want to exit from Basic, you can actually use the same operating system commands from Basic if you add an asterisk before the command. For example, cat. If you want to exit out of Basic, you can type asterisk by. There's a bunch of other commands you can use as well, like cd to go into a directory, for example. You can delete files. There's a command called credits. You can jump to specific memory address if you want to do that. JMP, for example. Load, we already seen. To load, you can make directories, rename, run, save. There's a set to set system options. And here I can see, in fact, there's a system option for keyboard. So set keyboard 7, which is Norwegian keyboard, is actually supported. Okay, let me try that in uppercase. Yeah, that works. So now we have, we have the Norwegian keyboard layout, but we don't get the Norwegian characters. This should give me a, ö, å, but at least it corresponds now to the layout of the keyboard, so I don't have to guess where the different keys are. Nice. So now I can actually just add that command to the auto-exec text, and it will do that automatically every time I turn on the machine. There's a time command, and it shows the time from 1970, so we can actually set the time then. And it uses a special format. Zero one. So now we have the correct time, and it's Monday. The MOS, or the machine operating system, also has an API if you want to program against this. So if I want to edit the AutoExec TXT file, there's actually no way to do that from within the MOS, but that's not an issue. Actually, you can just pull out the memory card and put it into your PC and then edit the file in Notepad or something. That's exactly what I'm going to do now. Yeah, and there's the command, so it already has a set keyboard 1 line there, so I changed that to keyboard 7, and then it loads BBC Basic, and then it CDs into tests, and then it runs it. And if we take a look at the tests folder, there's a lot of basic programs there ready to be tested, so let's take a look at some of those. You can actually reset the machine by using Ctrl-Alt-Delete. Yeah, and that's the so-called soft reset. Takes you back into the MOS command line. But now I'm going to do a hard reset, see if it actually sets the keyboard layout. And yes, it did. So nice. Okay, so as we saw from the startup script, it is starting in the tests folder, so we can take a look at what's there. And yeah, not sure if I've seen any of these before, but there's a lot of benchmark programs, different graphics programs, lines, circle, cube. Let's try and load cube.bas. And now we're into basic, and the BBC Basic has a load command. I don't know if it's case sensitive or not. I suppose it is. That loaded list. List. Yeah, that's the program. Let's run it, see what it does. We would like a solid cube. Let's try mode 0. I guess that's the graphics mode. Okay, so apparently it now uses a video mode that my TV does not support, because it says here it can't show this video mode. Let's try mode number 1 then. Yeah, that seems to work. Yeah, it's flickering a little bit, but remember, this is written in BASIC, and what kind of 8-bit machine could do this in BASIC back in the day? I don't think anyone could do it, not even Amiga. Okay, so I adjusted the camera a little bit manually now to get the more correct color representation from the screen, and this looks more correct. That should be red, but it's more like a little orange, but it's hard to get the correct colors when filming the screen. So as you can see, when you are in BASIC, it mixes graphics with the text. I suppose the text is also generated by graphics, so therefore the produced graphics still stays on the screen when you stop the program. Yeah, I think that was impressive. I'm gonna try something else now. This machine is capable of using sprites, so let's load some sprite program. I think there's already someone that has used this machine to build a games console or some kind of games console prototype. Not really sure about that. I think I heard something about that. Yeah, there's a bunch of sprites. Little Pac-Man enemies. Flickering a little bit, but hey, there's like 20 sprites on the screen at the same time as there's scrolling stars sideways. So yeah, this means that you can actually write pretty good games in BASIC for this machine, I would guess. Not that I'm gonna try to do that, but I'm sure there's already some games in progress for this machine. I'll look around a little bit, see what I can find. And now apparently it is rendering the shadows of those two balls or circles. Yeah, it now actually makes those spheres look a little bit 3D. So after booting the machine a couple of times, I was interested to see if it kept the time, but it does not. So now it's back to 1970, which is the year I was born. What about sound then? I didn't hook up a speaker. I didn't find one right now with a 3.5mm plug, so it has a little built-in buzzer. Maybe we can hear something through that. If you hear some noise, it's pouring down now, raining. And it hits my roof windows, of course, so yeah. Yeah. That's a tune, all right. Doesn't sound very nice through that little buzzer there, but I guess if you hook up a real speaker, it will sound much better. If you want to learn BASIC, then it's always a good idea to check out the demo programs like this. You see how things are built, and here we can see that it's just a loop and it reads 1 byte at a time from this data statement, and then it uses the sound command to play the sound. So benchmark programs that you can find on the memory card, and this tests the machine and times it, how long things take. And I've seen some comparisons and a lot of tasks. This machine is the fastest 8-bit machine in the world. Even faster than the Commander 16 on many things, I think. Scrolling. All right. That's some scrolling landscape there. And this is in BASIC, so imagine you just put the ship there and some enemies there and some firing capabilities, and then you have a game. Let's take a look at the scroll program. Yeah, there's not much to it. You set graphics mode 2 and then VDU. That's a special command that controls the video chip on this machine, and yeah, set some graphics color and draws and plot, and then the VDU 23, I think that is a scroll command for the VDP. The VDP is the video display processor that is in that microcontroller, as I mentioned. Mandelbrot. Yeah, and that starts rendering out the Mandelbrot set. Yeah, that's some kind of special algorithm that generates some nice patterns and graphics. I'm not really sure. It's kind of slow, but then it's slow on most machines from back in the day, and yeah, even faster machines today can actually use some time to produce this in high quality, I think. So this generates a fractal, and yeah, there's some special properties with that. It means that if you zoom in on the edges here, you will find copies of the same set. Numerical values, I guess. This is mathematics. Yeah, right, that took its time, but it's looking great. I think it took like 20 minutes, and now it's I think it's refining it a little bit more. So what about games for this machine, I hear you say? Well, I haven't really researched that a lot, but I don't think there's many impressive games as of yet, but there will probably be. I did find one game called the Oregon Trail. I think that's a well-known game for the Macintosh. So I downloaded that, see if we can run that. To run it, we type chain intro. Oh no, it says that the TV cannot show that video mode. Alright, I'm gonna hook up another monitor here, a little bit older VGA monitor, see if that works better. Yeah, this actually has built-in speakers, so I hooked up those as well. No, didn't seem to help. Oh, it just took a while and then it came. So press space to continue. I have no clue what this game is. Yeah, just looks like some text game. Kind of boring. So I was thinking maybe some of the BBC micro games can be used. Since those are written in BBC Basic, it should run on this. So I found this eggs game. Let's see if we can load that. Bad program. Okay, so that did not work. So that would have been a plus if you could load games you find for the BBC machines and run it on this machine. I'm pretty sure you can just change the format of the basic file. Maybe there's some encoding issues or something. So back to the other TV screen. Yeah, I ran this palette program that I think is supposed to show all the colors, but it looks kind of strange. I mean, why all these black colors here? Is that correct? It is supposed to have 64 different colors available and visible on screen at the same time. If you remember, the Commodore 64, for example, had only 16 colors. So I'm just adjusting my TV now so that it can show more of the actual picture in this mode, but this is how far I can get it, and apparently I cannot zoom, so I'm not gonna be able to see the whole picture anyway. That's a little pity, because that makes it kind of unusable on this TV at least. I'm not sure if there's any more settings here I can use. I mean, I can change the format, but that does not help, because it's still not visible outside the edges. Yeah, some more graphics demo. This is called Fireworks, and it's also written in BASIC. You can actually call machine code from BASIC. There is a demo program for that. I'm not gonna run that now, but yeah, the possibility is of course there. Yeah, and this is a line drawing program, and as you can see, it's blistering fast. So yeah, shows what you can do on this machine in just BASIC. Yeah, I think that was it for the demos that comes with this. I'm gonna check a little bit more, see if I can find some other software to run on this. So all in all, a great little computer. I really like it. But it is supposed to be able to run CP/M, so that's what I'm going to try out next. So I found a version of CP/M that has been ported to the Agon Light on GitHub, and downloaded that. Put it in a CP/M folder. It consists of a binary and then some floppy disk images. So let's see if we can run this. I'm gonna exit, of course, from BASIC first. Invalid path name, okay. cpm.bin. Oh, obviously when you are in the MOS interface, you need to load without the quotes. So it's cpm.bin. Yes, and run. Yes, there we are in CPM land. That's cool, and I know for sure that the directory command there is dir, and now we are on drive A. Yeah, look, there's CPM commands. So let's change to some of the other drives. B. What do we have here? Blackjack, chess, and basic. Well, I didn't find any particularly interesting stuff here, but yeah, Zork is there. Yeah, Zork is an adventure game. I think it's quite well known. Also, I saw some screenshot on the wiki page for this CPM that they ran Pascal. I guess that's Turbo Pascal then. You can program this with Pascal then. I looked around a little bit more. I found another game. Oops, error accessing SD card. Some temporary issue with reading from the SD card, obviously. So this one is called Rocky, and it's a binary, so it's not in BASIC. And it looked like a Boulder Dash. Let's see if this works. Yeah. Use cursor keys and press any key for starting. If you stuck somewhere, use the R to restart level. Okay, now we're talking some gaming here. Well, it's some kind of Boulder Dash clone. Probably made a mistake already. Let's see now if we can solve this. Oops, I died. Yeah, it was kind of fast-paced and responsive. Oh, I think I solved it now. Yeah! Okay, a little bigger board here. Yeah, and I found this game on GitHub, so the source code for it is there. I mean, if you want to learn to program this machine. I also found this basic game called Nova Star. Let's check that out. Alright, what is this? Yeah, okay. Press space to start. You exit warp and strike gold. You terrifying space bastard. Okay. Yeah. Looks like a nice little game. Perhaps a little slow, but maybe it speeds up later. But I mean, it's good to be in BASIC. I don't think you could write a game like this in the Commodore 64 BASIC, for example, without using some machine code routines at least. Yes, I cleared the level. Now level 2. Yeah, now it moves a little bit faster, and I can also shoot a little bit faster, so the timing algorithm is obviously a little bit, yeah, what should I call it, simple. So when it comes to programming the Agon Light, you have a couple of options. If you don't want to use the BBC Basic, you can do, of course, assembly. Zilog has tools for this CPU which you can use, and I think there's also some third-party open source tools for assembly programming, but bear in mind that this EC80 CPU is a little bit different. It actually has 24-bit address bus, and that makes it a little bit special to program in. You can program it in old set80 mode, but then you are limited to memory usage, I think. You can also use C. There is a C compiler that can produce binaries for this. However, there's some limitations there as well, because the C libraries need to be ported to the Agon Light, and yeah, I think there's only been done some very limited work there as of yet. Alright, let's take a look at something else. Maybe we can have some more fun with this. Since the machine has a Z80 and a ESP32 microcontroller and a set of I/O ports, you can of course connect some hardware and control electronics from it. So it's been a while since I fiddled around with the breadboards and LEDs and doing this kind of stuff, but yeah, I just set up a little breadboard here with one LED. Yeah, this I just place it there and go. I'm not going to use it now. It's just a 8-segment LED display. It's simply just 8 LEDs in this package, and you can turn them on and off separately. Of course, use a chip to help you with that if you have some serialized data. And also this button. So let's see now if we can turn on this LED from the machine from BASIC. The GPIO port on this, it exposes I/O ports from both the CPU and the ESP32. I'm not going to go into how to program them via the ESP32, but I'm going to use the Z80 and just need to figure out what the pins are and which port to connect to. I found this diagram here over the port, and yeah, there's a couple of pins with the ground, and then we can simply select one of the GPIO ports here or here. Only need to figure out what is up and down on that port. I just measured with the voltmeter on the contact, and according to the diagram, pin 2 is the only place that has plus 5 volts. And that is actually that pin, so that means this is pin 1 and 2 and 3 and 4 and so on, and we have ground on pin 3, so it means we should connect 1, 2, 3, there's ground, and then I just find one random GPIO port to connect to. Hopefully there's some built-in protection. However, I have put the 330 ohms resistor in series with the LED, so try not to pull too much current out of this. Actually, I changed my mind. I just want to be extra careful, so I'm using a 470 ohm resistor instead. Alright, so I hooked it up to ground and pin 17, which is GPIO port 0. Of course, while the machine is powered off, let's plug it in, see if we broke anything. Yeah, there's a faint glow in the LED already. Probably that means it's on by default, or it might be configured for input. I'm not sure. I just need to read the documentation a little bit first. Now, to read data from the GPIO ports, you use get command, and to set the data you use the put command. So we can actually check that with the print get, and we just get a value from some registers. I'm not gonna go into details here, but address 159 is supposed to be telling us whether the ports are configured, the 8 ports are configured as input or output. Yeah, and that resulted in 255. That means all the ports are configured now default as input. So we need to change that. And for that we use put on the same register. And set them all to 0. Yeah, and that actually turned on the LED now. Let me try and just change it back to 255. Yeah, it's off, but we want the ports to be configured as output, so back to 0. So now, how do we turn on and off that port? Well, it turns out just issue a put command on address 158, and that is GPIO port 0. Yes, that turned it off. And the 1 turned it on, and the 2 turned it off, and the 3 turned it on. So yeah, let me just show you. Off, on. Cool. We're controlling the LED from BASIC. Now I'm just gonna make a little program that blinks it. Just writing some put statements here. Go back to line 20. Yeah, let's run that. So it went a little bit dimmer, but it's not blinking, at least not that I can see, and that is probably because it runs too fast, so we can't see any delay between. So I'm just gonna try and add some delay. Now I couldn't really find a way to delay the code. I Googled a bit, and there's supposed to be a wait command, but it's not supported here. And you can of course use some for next loops or something. I don't want to mess around with that, but yeah, instead I thought maybe try and use a key instead to blink it. So I'm using the in key command. So now I run this, just press a key, and the LED blinks. Great. Okay, that was fun. Let's check out the input then. I have this button. Let's see if I can use it to command the machine. I just moved the 2 wires over to the button, and yeah, that's a clicky button. And I'm using the same I/O port. So those are the same pins. And now I'm going to configure it as input. So here's a little program I made. Put 159,255 sets all the I/O ports to input. And then I just get the value on address 158, which is I/O port 0. And yeah, if the value is 0, then the key is pressed. If the value is 1, then I just print a dot. There's no delay or anything in this loop, so it will probably run very fast, but yeah, that should work. Let's run it. Okay, it prints a lot of dots, so the button is not pressed. Let's push it then. Yeah, pressed key. So with this I can make a small joystick if I want to. So I'm not really sure if these ports have some internal pull-up resistors or something like that, or if you're actually supposed to have that yourself, but at least it is working, so that's nice. Very easy. So I just want to save those programs, so I just use the save command, obviously. And that saves it to the memory card, of course. Yes, so that port actually opens up a whole world of opportunities if you want to do something fun with this. You could, of course, connect some display like OLED or LCD display, or something more advanced like a Wi-Fi module or something like that, and get this machine online. That would be cool. I think we're close to the end now of this video, but before I conclude, I actually want to find a case for it, and I found this one. Looks to be the same. Only thing I had to do was to modify it a little bit, because it's designed for a USB-C or micro USB contact, I think, and this one has a USB-A, so just cut a little bit off there and this should work. Only thing, it takes 4.5 hours to print. Oh well, that's unfortunate. That's something that happens from time to time with this printer. I finally got the print going after 3 tries, and yeah, I just had to clean the print plate really good. While we wait on the print, I'm just gonna test out some other stuff, and just to mention, when I downloaded that eggs game that wouldn't work, which I downloaded from the BBC Basic Archive, I took a look at the file to figure out what was the difference between that basic file and the ones that are already on the memory card, and the only difference was that the line feed characters were different, so I just changed it to CRLF instead of just CR, and then it actually loaded. So here is that eggs game. However, it doesn't work because yeah, it runs, but it is actually, this computer is actually way too fast. So it's impossible to see what's going on and do anything. So yeah, game over. But that proves that you can download the basic files from the BBC Basic Archive and just have to convert it to CRLF line feed characters, and then it should load. Just one more little game I want to show you. This is kind of simple game, but yeah, it's written in BASIC too, so you're supposed to collect the pizza and avoid everything else. Oops. So the case finally finished, and yeah, it came out really nice once I got the printer correctly set up, and yeah, looks very nice. I used red because I have a lot of red, I need to use it up. So this case is not perfectly fitted to this board because this board has a USB-B connector. I said A before, but this is a USB-B. And the case I found for the original board was for USB-C or A, I think, I don't remember. However, I just cut a little bit as I showed you, so let's see if this will fit then. It might not fit perfectly. I might have to do some adjustments. This side fits, but on this side the GPIO contact here is too wide for this case, so I need to cut it a little bit. See if I can fix that, and then maybe I just adjust the model later and print a new one. Let's see now. Yeah, I'll clean it up later with the file. Yeah, I think that fits with the screw holes and everything aligned, so... Oh, of course I need to cut on the other side as well. Yeah, that works. On that side, almost a good fit. This one looks a little bit ugly, but that's how it is. So, just need to find some screws and we are done. Alright, that was it for this video. Really happy to have tested this out. A great little machine and a great platform, I think. It still needs some time to mature, to get some good innovations out there, some games, maybe some game engines or other tools and software for it, and other extensions for it perhaps. I would love to see this online, for example, and hopefully there will be some progress in the operating system and things around there. There is a community out there that is working with this, and I know there's someone making a console now with this as a platform, so it will be interesting to see what happens. So where can you buy this? Well, you can buy it from PCBWay. Actually, you can either buy only the PCB itself and then populate the board with the readily available parts that it needs. So that's one possibility, or you can purchase a completely built board from PCBWay also. So check out that. I'll link to those in the description. Otherwise, you just have to check around. There are other sellers. I'll link to some of the others also in the description, and I'll also link to the documentation and the GitHub pages and so on. So check below the video. So that was it for this video, as I said, and thanks a lot for watching, and thanks a lot for all the subscriptions and the comments, and a special thanks to my patrons. See you, bye bye.